you, Alice?
I'm good, how are you?
I'm good. Oh, I feel so far away from you today.
I know, it's really sad.
We're usually on the same side of the table, but we're on opposite sides of the table today. You'll find out why in a second. And I feel really, distant. I can't look at you. The mic's in my way.
All I can see is our new fluffy microphone thing.
Yeah.
What's it called?
I don't actually know. I think it's called a pop filter, I think.
Ah.
But the classical pop filters, they're like a little ring that they hold in front of the mic. But because we're recording from both ends and I didn't want to buy two, I just bought this sock thing that goes on top of it. Yeah. To be honest, I think I could have put a sock on the mic and have done the exact same thing.
So if you're wondering why we sound completely different, it's because of our new sock.
Hopefully it sounds better.
Yeah.
Yeah. It's meant to cut out all the harsh P's and K noises and stuff.
The P's and K's?
Yeah.
Are they the harshest sounds that you can think of?
No, that's genuinely.
That's what it's written in the description, is it's going to cut out all the harsh P's and K's.
That's what pop filters are for. They cut, because P's and K's sound really harsh. I think audio recording equipment picks it up in a certain way that it can sound really harsh.
Interesting.
Yeah, and my guest next to me, I feel like, is dying to make some comments right now. I have something to address from the last episode.
Do you, Curie?
Yes, I
really?
do. As always, I think we should start. I think we need a segment. We need a jingle for Curie's rant corner or something.
I don't even need to ask you how you are anymore because you just launch in. You don't even need to be asked.
Although actually, this isn't a rant. It's more of a maybe a little bit of an apology. So.
Oh no.
I noticed when I was editing, and then someone also noticed when they listened back that I displayed an implicit gender bias against structural engineers. So the bit where we're talking about the Sainsbury's car park, and I said, oh, the structural engineer did a terrible job. I said this guy. So when I was editing back, I realised that I'd potentially gender biased this structural engineer as a man. And my friend also commented on it when she realised. She messaged me saying, it's interesting that you said this guy when you were talking about the structural engineer. And then Demelza also said, it's interesting that I thought that considering our guest who was a structural engineer was a woman. Anyway,
oh, shit.
I was thinking about it, and first of all, I realised that my gender bias wasn't towards the fact that he was a structural engineer. It was towards the fact that they did a terrible job. So, there we go.
So apologies to all you male structural engineers out there for being implied to be a bit shit.
Yeah. Actually, no apologies. I take it back.
So what was that whole part just about?
I was apologising for potentially doing a gender bias, but I realised I wasn't. I'm going to cut this bit out because now we're just talking about shit.
You are going to cut it out. No, I'm going to cut it out.
going to cut it out.
Apologies if this week's episode makes no sense because it's my first week editing. Yeah. Probably cut this out too, but if anyone's interested.
Also, just a quick update. So 2 episodes ago we did our little rant about the science about how you shouldn't do science communication over Instagram.
That was published in Science.
Yeah, and
targeting some specific people.
It was targeting Science Sam and just general female Instagrammers. Science have published another article written by another group of communicators. One of the authors is Science Sam.
Oh shit, I didn't realise that.
Yeah, basically arguing against it, and they raised very similar points to what we did.
Which I think was probably a general opinion amongst scientists.
Yeah, exactly.
Was that the arguments were weak, to say the least.
Anyway, you should go read it. I'm sure Silent Demelza would be so kind to post a link on the blog. I just think it's hilarious that the same journal that posted that first one in the first place then posted the exact
retraction.
Almost exactly 2 weeks later, an article saying that article was shit.
Perfectly timed for our podcast.
It's like
Thank you, Science.
It's kind of reminiscent of how the Sun has to apologise for something they've written about every week.
Yeah, very similar.
Yeah.
Except in science. See, we can be interesting too and scandalous. So,
yes.
Are we going to introduce our guest, or do you have more to talk about?
I don't have anything else. Reese, hello!
Hi.
Welcome.
Thank you for having me.
God, your voice is going to sound great on this.
Yeah, Curie was really excited. She texted me during the week and she was like, the accents are going to be all over the place this week because we have,
going to be some good diversity of accents in this.
Yeah, very diverse.
We have Irish, Scottish, London, and then some sort of North. Although apparently not North. We'll find out.
Yeah, we're not really sure.
Yeah. So
we'll ask him later.
Yeah. Tell us a bit about yourself. What do you do?
Okay, so I work in tech. I'm a product manager in a tech company called RateSetter. It is not my background at all in terms of tech. I've managed to stumble my way into tech. However, I ended up studying earth science at university. So I did an undergrad in earth science.
Yeah. So we have another layman who is a scientist.
Yeah. Just for all you listeners out there, we're running out of non-science friends. If anyone wants to come on our podcast.
Yeah, I'm trying. I'm trying to find some more non-science friends. It's hard.
It is quite hard.
Yeah, I don't think I'll know much about it today though. I know rocks.
Yeah.
I know things about rocks.
Oh,
rocks
so
are great.
What's your
rocks.
opinion on crystals?
Yeah.
Right, so I watched this video, a YouTube video from a YouTuber that I actually really like, and it was about her crystal collection. So she has like rose quartz and
this is that thing about how they like balance your life.
Yeah, so she was talking about all like the energy in the crystals, and she's like, sometimes I like to touch this one when I need to clear my mind. Keep this one by my desk because it channels this creative energy and blah blah. And some stones you don't want to touch because they can take in negative energy, or you need to cleanse them regularly so that you can cleanse all the negative energy that it's taken in. And then she was saying like, I don't let my guests touch this rock because it does absorb any negative energy, and you don't know what energy that person's feeling. And I was sitting there like, what the fuck are you talking about? This is the biggest load of shit I've ever heard.
Yeah, I did the whole module on energy.
The flow of energy through rocks.
Kind of somehow skipped that in the syllabus.
It was so culty. It's just so culty and hippie, and she's really relying on these rocks to, I don't know. I mean, I guess it's kind of nice to put faith in something, but
you're just giving control of your life to an inanimate object.
to a fucking stone.
To know an array of stones. Actually, there's several
Like,
of them.
they're really pretty. They're really nice to look at, but it's not going to give me any fucking positive energy. I'm not going to be bored for ideas one day and I stare at a bloody rose quartz and I'm like, oh, ding!
You don't stare at it, you should like stroke it.
Oh, okay.
Yeah.
Maybe I'll just put it next to my bedside table.
Caress it.
Caress the rose quartz. So, okay, would you consider yourself a scientist?
I have a science education, but I wouldn't class myself as a scientist.
Okay, cool.
So I'm quite far away from that now. I did a master's in something fairly similar, but I then pretty quickly went into tech, and I kind of touch in computer science and other things like that, but no, not sort of pure science anywhere near anymore.
When we both first met Reese, he had one of the coolest job titles I'd ever heard.
Yeah, so the first job that I had, so my master's was I specialised from earth science into natural hazard modelling. So that's what it sounds like. It sounds like earthquakes, hurricanes, floods, all of these things, doing probabilistic modelling to actually figure out the risk of these things. And then I actually joined a software company, a tech company that did this. They basically created probabilistic models that allowed you to calculate the probability of something happening, and we had lots of people that used our models.
So were you predicting earthquakes?
So it's not prediction because it's probabilistic.
So you were probabilizing earthquakes.
Yeah, if you want to make up that term, go for it. Yeah. So those models, the kind of grandiose title for those models were called catastrophe models.
Oh, unreal.
So yeah, my job title was catastrophe consultant.
Oh,
amazing! So that's by far the coolest job title ever.
Yeah, that's pretty funny.
Yeah, it makes you sound really MI5.
Yeah. Oh god, that's just so cool.
Yeah.
And what's your job title now?
It sounds not as cool. It's a cooler job, but it sounds not as cool. It's just product manager.
Boo.
God. You should go back to being a catastrophe consultant.
Yeah. No.
Or talk to your current employers and see if they can par your previous job title. So you have some job dissatisfaction based on your title.
Silent Demelza gave herself a snazzy job title because every time people ask her what she does on the podcast, she's never not sure what to say.
I like to refer to her as producer Demelza, but she doesn't like that.
So I think it was executive quality consultant. Kind of snazzy. I think it's better than fact checker.
Probably better than fact checker, yeah.
If you've listened to a few of our episodes, Reese has actually made an appearance on the podcast before.
He has.
In the form of an anecdote about some weird ass little kid who used to lick batteries.
Who apparently is a kindred spirit to many other weird ass kids out there. We love you all though.
I had to occupy ourselves somehow in childhood in Scotland.
Give us the description you gave earlier on about the specific batteries that were your favourite.
Yeah, it's I forget what they are. They're like 1.5 volt or 3 volt or something like that. The little like cube ones that have the 2 ports on the top so that you can get your tongue on them. Firm.
Oh, yeah. Nice. Yeah. More surface area.
Yeah, exactly.
For the reaction.
So then it kind of feels like it's kind of all metallic and like your brain's getting a bit
still fucking
fried.
weird, man.
It was great times. Great times as a kid.
But I mean, then he became a catastrophe consultant.
He did.
So it can't have
Maybe
been that bad.
Yeah.
the lightning started on your tongue. And you know what? I don't get offended easily, but I think I was pretty offended when you then looked at me as if, of course,
I don't know,
of all people to lick batteries, it's got to be
I
me.
felt like we had similar childhoods. Apparently not.
Haya always refers to us as twins because we have really similar tastes in everything.
Yeah.
So just to give context, Haya is our friend and colleague, and Reese is Haya's boyfriend, and we are hoping that Haya will be coming on the show in a short time.
In a few weeks. She has her PhD Viva soon, and then she'll be on after that.
Woo, go Haya!
Yeah, so Reese and I have really similar tastes and stuff. And it's just like random experiences that we have are the same. Like we cried to the same movies that no one else cries to.
Oh, what?
Hong Kong. No, Hong Kong. King Kong. Sorry.
King Kong. Yeah.
Which one?
The newer one. Yeah, I was in hysterics after King Kong when they
Yeah.
killed him. Oh, spoiler alert, sorry.
Anyone who's not seen Hong Kong is going to be
King
devastated.
Kong!
Sorry, I've started something here.
You really have. And actually, I had Hong Kong on the brain because I got an email today from somebody who's having a conference in Hong Kong.
Oh, are you going to go?
No, it's one of those spam ones. I never know if they're legit.
Oh.
You know, it's like a global something or other, and they're like, come join our conference. We have like 2 speakers. We can't release the agenda because we don't have enough speakers. But please come. I'd love to go to Hong Kong, but yeah.
Hong Kong...
You tried. You were, it was like almost there.
King Kong has been remade so many times now. If you don't know the story, then...
Most
Although
people know.
people always say this to me about things like Game of Thrones and Walking Dead, I caught up really late and I really avoid spoilers. And then I get pissed off when people tell me spoilers. And then they like shout at me being like, Kiri, that came out 10 years ago. Blah, 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 blah. You shouldn't be surprised if you get a spoiler. I'm like, yeah, I've gone 10 years having no spoilers.
But that's because you probably did have spoilers in those 10 years, but they weren't on your radar.
No!
No, I disagree.
No, things like Game of Thrones, you cannot... They are everywhere. Even if you don't care about Game of Thrones, people knew spoilers from
that's
Game of
impressive,
Thrones.
like,
And I didn't know
any social
anything
media.
until I was at work and people ruined some very big things for me.
But do you not think it was everywhere, but you were seeing it?
No,
But you just weren't taking it
I would
in.
avoid it because I knew one day I'd watch it.
Okay.
Subconsciously.
Interesting.
I didn't make an effort to. It just happened. And now I'm catching up on Grey's Anatomy and I know something really big happens. And I'm really sad about it.
Did you finish The Walking Dead?
No, I've got one more season. I'm on season... What's the season where Negan comes in? Season 7?
Yeah.
I'm on season 7. Sexy Negan.
Oh, no.
No, because...
Hang on, did the really awful thing happen yet?
No. I know what it is, but no.
Oh, okay.
I know...
Oh, who told you? Last time I talked, you didn't know.
My sister accidentally told me.
Oh, no.
Yeah. Well, I thought it had already happened. And then the way she reacted, I realised that wasn't it.
Yeah, okay.
Yeah.
Yeah. Oh, no.
Sorry to anyone that doesn't watch Walking Dead.
And your job takes you to some interesting places, doesn't it, Reese?
I've been around. What are you
I'm specifically
insinuating?
referring to a little work trip that you had very recently.
Oh right, yeah, I was in Ukraine. that was interesting. Yeah, big business city.
Yeah,
like,
huge
yeah.
business.
Yeah, no, I was in Ukraine. I've got developers out there. That's where all my programmers, not all of them, but some of my programmers are. So I was out there visiting them, you know.
Wonderful, and they were showing you all the local delights.
Yeah, all their wide, vast array of horribly flavoured vodkas that you wouldn't even expect to be flavoured. Things like horseradish vodka and soup vodka.
Oh,
and,
soup
yes.
vodka.
Yes, soup vodka.
Well, any particular soup or
Borscht.
Oh,
Borscht,
so
which
Thing
is
is,
beaver
I can-
soup
European.
vodka.
Yeah,
I can actually imagine a borscht vodka being quite nice. But I kind of imagine it to be... Because if you warm up vodka, you can't really taste the vodka-iness. So then I just imagine it to be like, if you warmed it up like you would warm sake, then it's just like drinking some borscht with alcohol.
Yeah, they didn't warm it up.
It was cold. Was there bits floating in it?
Yeah, it was kind of bitty.
Ew.
Like,
I kind of want to try it though.
Yeah, that's because you're weird though.
We have another guest.
And Curry's gonna give him a warm welcome.
No, it's not that bad. This is our most opinionated listener.
Who has been there from the beginning. He actually helped us do our first sound test.
Okay, let's just introduce him first. This is Rob.
Hello.
Rob
Welcome, Rob.
Thank you.
Rob is Silent Demands' boyfriend and the harshest critic of the show. Literally every week after the episode comes out and Rob has listened to it, Jamalza will come into work and she has a list of comments that Rob had about the show.
I feel like I've been stitched up here though, because it's not like I just come in and I sit Demelza on the couch and just start lecturing her about how she should do things better. She like asks me what I think and I go, yeah, it's really good. And then she's like, oh, okay, but like, what do you think? And I was like, no, I thought it was really good. She's like, anything you do differently? And I was like, well, if I had to say one thing, I'd say this. And then I'm assuming she comes into work and she goes, Rob said this, without any like context. So I feel like I'm being
Unfairly
yeah,
victimised.
exactly. But I am aware that I am quite critical. But it's only because I care.
Thank you, Rob.
To be fair, is he the first person that we know of that actually has listened to every episode that we know?
I'm a
No,
subscriber.
other people have.
But are we sure that they
Dan
have?
has.
But they're both boyfriends of the show.
Yeah, that's true. They have to listen to it.
There's no other choice.
Well,
I just want it to be the best it can be.
so do you know what?
Thanks, Rob.
I think the hurt started before the comments of the podcast.
Oh, really?
Because the second time I met Rob, he had no idea who the fuck I was.
Well, I was handing out name tags, and Kiri came up, and I thought I recognise this person, but I'm not really sure where. And then I asked, "What's your name?" She goes, "Kiri," and I went, "Oh, someone in Demelza's lab's called Kiri." Gave her the name tag, but it just didn't click that they were the same people. So yeah, I apologise for that.
Wait, did you say out loud someone in Demelza's lab is called
No.
Karen?
No, I just thought it to myself, and then
He thought it to himself. I was looking down at the name tags and being
But
very unfriendly.
I was so. It was so hectic that morning, so much had gone wrong. I won't go into
So
it
you're having
now.
a stressful day.
Very stressful.
That was a stressful day.
I only did it so I could write the quiz at the end.
It was a good quiz.
I know.
Had lots of comments about our pub quiz too, didn't you? Demelza and I organised a pub quiz at work recently, and
I just answered the questions.
with a lot of opinions to go with them.
I didn't think I did. What did I say? I clearly just have opinions about realising.
What are your arguments like? Because you're both very opinionated people.
We don't really argue that much, to be honest. We argue about very mundane things. What did we argue about last time?
She can't
She
talk.
can't
without
talk.
asking her
Oh, this is brilliant. I
questions.
should take
You
all the
can-
opportunities.
You can say whatever you want and she
Yeah.
can't refute it.
I think we rarely argue. I think we get our arguments out with other people, so when we come home, we don't have to argue about anything.
Is that why you like to wind up Curry?
Yeah.
Yeah.
But I'm winding up Kiri vicariously through Demelza, so
Yeah.
it's
Yeah.
not. I don't
Well, you
get.
know
I don't
where-
get the reward of seeing the
Yeah.
wind up. So maybe I will. tonight.
Demelza gets the reward instead.
No, do you know what it is as well though? The thing is, it's one when you emailed Demelza randomly saying, "Oh guys, you should do this sort of episode and this sort of episode, and you should talk about this paper." And then I said to Demelza, I was like, "I bet Rob just really
That's a
wants to come
gross
on the
exaggeration
podcast."
of what happens. I'll tell you the exact story of what happened. It's quite sad and reflects badly on me, so I'm sure you'll like it. I was bored at work, so the paper that I'm going to go through today is one I had to critically evaluate for a piece of coursework, and it's the highest mark I've ever got on a piece of coursework.
Oh.
What was it?
95%.
Jesus!
I didn't think those kind of marks existed.
Right? Fucking hell.
Neither did I until I got it.
What happened to the other 5%?
I'm not sure where I lost it. I was pissed off about that. But anyway, so I was bored at work, and I was like, I'm going to read that piece of coursework I did again to give myself a little self-esteem boost.
I'm just going to read my head.
I was like, oh, you are a good writer, Rob. Well done. But then, I was reading it, and I was like, oh, this would work well on Dee's podcast.
Didn't you say we should have a dinosaur special?
Well, no, then Dee DM'd me back, and she was like, Kiri says you could come on the podcast. And I was like, oh, yeah. But then only if I can do a dinosaur. So the coursework I got my second highest mark out of it was a course I did at uni called Evolution in Deep Time. I wrote an essay called How Dinosaurs Got So Big. And it's my favourite.
Hang on. Wait, you were in uni when you wrote this?
Yeah.
At what age?
Like, what were you when you found it? Like 21? 22? It's my
I feel like
favourite.
my brother wrote a similar piece when he was 12.
I feel like you have a folder on your computer that's like my sad day folder. And it's got all your best marks.
So I'm so annoyed. So I got a new laptop when I started my PhD, and I forgot to transfer that file over. So I don't know where it is.
No!
Oh God.
But the reason I like that essay is because I sent it to my brother to proofread, and me and my brother are very competitive, and we never really give each other compliments. And he just sent it back, and he went, Yeah, it's all right, that. I was like, oh,
that's
cheers,
really
James.
cute.
Yeah. If you get the chance, we should do an episode on it. It's so
Okay,
good.
fine.
Well, because of our need to recycle guests, that probably will be sooner rather than later.
So I dispute I have a northern accent. I think.
Well, that's
people
the thing is, I thought you sounded really northern.
I think
and
Curry
then
falls into the camp of southerners who think
anyone
anything
above the Thames is
Yeah.
north, and anyone above London is north. So then I asked Demelza, and Demelza couldn't really define where your accent was from. She said your family's from Wales.
No. Well.
Rob's from Wales. You are Rob.
Kind of. So I have a massive.
Rob, you explain.
I have a massive mismatch. So mum's from Sussex, dad's from Essex, but then they both moved up to Chester, which is near North Wales.
And then Demelza did say Chester, and I said, oh wait, yeah, he does have a really Chestery accent.
Yeah. So
Yeah, you do.
I grew up in a village.
Alice, you know what Chester is? If I gave you a map right now.
No. That's not.
Yeah, I grew up in a village equidistant between Chester and Wrexham,
Right.
which is a town in North Wales, but my house is about that far in Wales because of
How
that.
far is that? This isn't a video cast.
Oh, sorry, yeah. For the listeners, I place my hands about 30 centimetres apart from one another. So yeah, right on the Wales-England border, but that meant I had to go to a Welsh school, so I did a lot of Welsh.
So
I
can
had
you
a lot of
speak
Welsh friends. Very poorly. Not what I would call fluent.
I've been to Wales before. For like 5 minutes in my car.
But when we were counting the countries we had been to, you weren't allowed to count
I wasn't
Wales.
allowed.
So actually you can't say you've been
Yeah,
there.
I was driving back.
You didn't even realise you were in Wales until you were leaving it.
Yeah, no, I was driving back home from Somerset back to London, and one of the motorways goes through the border, like through the edge of Wales. So it goes slightly into Wales and then back out. And as I was leaving, it was like, you are leaving Wales, and I was like, oh shit, I was in Wales. This is so cool.
So yeah, but like I essentially feel very under pressure to perform now because of all the
Criticism.
I'm
gonna be
constructive criticism.
I'm gonna
add.
be well harsh on your shit, although you probably know a lot more than me, so I probably won't.
See, that's the good thing for me. I just need to be dumb.
Yeah.
I just need to.
That's all you need to do. You have the easiest job here,
Yeah.
really.
Yeah.
It really did motivate me to prepare today, so I've spent literally all day like
Aww.
taking notes on this.
We have
That's
such
cute.
dedicated guests.
I know.
Taking notes, preparing.
I heard your biggest complaint though was about my knowledge of electrophysiology.
That literally wasn't my biggest complaint. Where are you getting the D is giving you such false information?
No, that's an interesting point because what was your biggest complaint in your opinion?
Oof.
It's alright, go for it.
So many to pick from.
Do you want to take your list out?
I've never written them down. I don't know.
I'm surprised.
Yeah. Are they not in a file on your computer beside them?
No.
When I'm sad file.
No. My biggest complaint is you don't have a general intro, which I think we need.
Oh,
God.
we're
We were
working
talking
on
about
it.
it.
We're
Yeah.
working on
Sore
it.
topic.
Yeah.
We're trying to come up with a tagline.
Yeah, we'll sort something. If anyone has any ideas, do tell us.
Someday soon.
Yeah. Should we
So-
talk some science?
Yeah, well, we asked Rob where his background is.
Yeah. I bet you were one of those really annoying nerdy kids at school that like knew everything.
Yeah. No, not really. So I had a really good biology teacher. I think that's what got me into science.
Mm-hmm.
And then from there, just did biology, chemistry, maths at A level, and then could never decide which one I liked the best. So I went and did natural sciences at uni, which I think is the story of most natural sciences students. That's where I met Demelza.
Cute.
Do you want to hear that story? She told me not to tell it on the podcast.
Yeah.
Oh,
Yeah.
God, yeah, you're
Sorry.
definitely telling it.
Yeah. So I met Demelza in Freshers Week on the natural science first social.
Sexy.
Exactly. And because
Love is in the air.
it's natural science, the theme was come dressed as anything beginning with N or S.
Okay.
Interesting.
So about 80% of the girls came as schoolgirls.
Oh,
It's the
lame.
most unimaginative thing I've ever
Did
seen.
Demelza come as a schoolgirl?
Yeah.
Lame.
Ah,
I expect more
Demelza.
from you, Silent
I
Demelza.
think the phrase is
Disappointing.
a basic bitch. Am I using that correctly? And then I come as a...
How old are you? 70? Oh, what's that word those young kids use these days?
I'm not up with the lingo. My friend Emma, who I've told to actually listen to this podcast when it comes out, taught me that phrase last weekend.
Oh my god.
Last weekend. Rob, why did you even admit that?
So yeah, I'd gone with my friend Marcus dressed as a Smurf. Both of us were Smurfs.
Nice.
Fairly original. And we turned up, introducing ourselves to each other. And back then I was a bit of a knob. So I was like...
Back then?
Yeah. And Demelza introduced me to her. I asked her what her name was, and she said Demelza, which, as I'm sure you all know, is quite an unusual name.
Mm-hmm. And
I was a bit drunk at the time, so it didn't really stick in my mind what her name was. So I spent the entire night calling her Esmeralda. No matter how many times she corrected me, I was just
sorry, can I butt in? So
This week?
where
were we?
We were at Reese's place with Haya, and we were talking
We
about...
haven't actually even told Demelza this yet, have we?
No.
So we were talking about the podcast, and we were like, oh yeah, the two of us and Demelza. I kept mentioning Demelza and the three of us and how that's his house we were going to, etc., etc. Then we just started talking about the name Demelza.
Yeah, because
And
Reese
we were
and Haya had never heard the name Demelza before.
No, never.
Yeah. And then we just started having a little discussion about Demelza's name, and then ended up Googling where her name came from. And I was in the camp of it's not Cornish. Everyone else said it was Cornish, and I was wrong because it is Cornish.
Definitely Cornish.
And hang on, I even figured it said what it meant. It was like something about sweetness.
And something about a fort on a mountain or something.
Fort on a mountain, but then it said that's...
Yeah, you could translate it further into sweetness.
Yeah, because Melza meant honey or sweet.
Yeah.
Which is isn't miel honey and miel in French?
I don't know.
I'm pretty sure it is.
Yeah, but then also, you thought we were saying Esmeralda, right? Or you said you'd heard of the name Esmeralda, but not
just
Demelza.
never Demelza.
Yeah.
So is Esmeralda Cornish also?
I don't think so.
No, it sounds like a Disney character.
Fact check that now.
It is a Disney character.
It is from The Hunchback.
Oh,
Notre Dame.
Yeah, it's from Disney.
Yeah. Sorry. Anyway, continue.
So yeah, I'd seen her, I thought she looks alright. I'll try and talk to her, but then I assumed I'd ruined my chances.
She looks alright.
Yeah, by calling her Esmeralda the entire night. So when I woke up in the morning, I was like, oh, that was a silly thing to
What
do.
did you wake up on your own?
Yeah.
Yeah, that's not.
He
Kiri.
woke up thinking about
I went to check my Facebook account, as people did back in 2010. Don't know if they still do. I still do, obviously, because I've only just
Don't know what
learned
those kids do
basic
these
pictures.
days.
Yeah. And I'd got a message off her saying, I really liked your dancing last night. And
Demelza made the first move.
I'm fully aware of how... Well, yeah, that's
Did
what
you
she
get
said.
fraped?
Yeah.
I'm fully aware of how bad my dancing is, so I was like, she didn't like my dancing like that. I knew what was going on there.
Oh, very sharp.
Yeah, I know. And then from there, it just went, and now, nearly 8 years in.
Cute.
That's a lovely story.
It is. Yeah. So yeah, I did natural science at uni, and then me and Demelza were both doing a course where you went on placement for a year. Mm-hmm. So I went to America to do a placement, and then came back and did a master's year at Bath. In the meantime, Dee left to come to London to do a PhD, and I decided to follow her and did the exact same course as Dee, where I'm now doing my PhD.
Nice.
Lovely.
Welcome.
And what is your PhD?
Well, I think the official title is Biomedical and Translational Science. I basically work on autism.
Quickly, before Rob tells us about his PhD now, before we get into some science, this episode's a little bit different from the other ones, and it's just going to be Rob talking about his work, and then he's brought on a paper. We thought it'd be nice, seeing as we bring on a science guest, to focus the episode on that guest, rather than having me and Alice
talk about poo and brain cells all the time.
Yeah, I thought maybe
so you guys get a taster of something slightly different.
Yeah.
So yeah, in a nutshell, I would say I work on autism. Mm-hmm. But in general, the lab I work in focuses on the impact of epigenetics upon brain development. Sorry, my drink is very fizzy for some reason.
Effervescing.
Yeah. So I think I've used my first jargon term there in epigenetics. So I don't know if
Yes,
do I have to defer to Reese
first
to
question.
see what
Explain epigenetics.
Yeah. So epigenetics, I think, is a term that's starting to filter through to public consciousness, but I don't think it's quite ingrained yet.
It's on the way.
It's on the way. So essentially, it's an umbrella term that refers to anything that affects the expression of your genes that doesn't actually change the DNA. So again, going a bit further back, your genes are made up of DNA, and if you get mutations in your DNA, that can change the expression of your genes.
And lead to diseases.
Sometimes
lead to nothing.
Sometimes lead to nothing. Depends what the mutation is. But epigenetics is a bit different. So epigenetics changes the things that cause your genes to be expressed. and in that way alter how much they're expressed. It's quite a hard thing to get your head around. But I work on a specific type of epigenetics called chromatin remodeling. And again, more buzzwords. So chromatin.
It's full of buzzwords.
Yeah. So the way I like to picture this chromatin remodeling. So if you imagine every cell in your body has about 2 meters of DNA in it. One long stretch. Well, not one long stretch, but a long stretch.
How many cells do we have in our whole body?
Trillions, I believe.
Oh, okay.
And each one of them has
2 meters.
2 meters,
2 meters.
of DNA.
If you
'Cause you could-
stretched it all out and flattened it all out.
Yeah.
As a double strand.
As a double strand.
I remember something coming up about how if you linked all the DNA that you have, so like took it out of every single cell, it would like wrap around the world like maybe a certain number of times.
Oh, really?
Yeah,
Probably more than this.
yeah, more than once I think.
Yeah. Imagine that's quite a lot of material to fit inside a tiny little cell. The approach your cells take to doing this is they wrap your DNA around proteins called histones. So the way I picture it is imagine cotton thread wrapping around a bobbin. So the thread is your DNA and the bobbin is the histone.
Okay.
And
Translation of bobbin. Spool.
Is
So
it the
are we
middle?
literally just talking about it going round like
A spool of thread.
nothing special, just round and round?
It's the
round.
middle bit of string. Like if you get a reel
Yeah.
of string, it's the middle plastic bit. Is
Yeah,
that
the
what
plastic
it
bit
is?
in
Okay.
the middle.
Yeah.
yeah.
Okay.
So the reel, the spool, the bobbin is the histone, the DNA is the thread, and the histone and the DNA together are chromatin.
Okay.
It's called a complex of DNA and histones. And then your whole genome, all the DNA in your body, is wrapped around multiple histone proteins. So you get like a sort of string of these bobbins wrapped around, the thread wrapped around the bobbins to create this big long string like pearls on a necklace.
So is there one histone per cell, or are there many histones?
many,
per cell?
many.
Right. Okay. And then DNA wraps around many.
And
different
then
histones.
when you...
So you have a string of pearls in each cell.
Exactly.
Oh, that bit. Right. Okay.
And
pearls,
then
yes.
if you bring all of those bobbins and string together into one structure, that is what's called a chromosome. And I'm pretty sure chromosome, I think, is quite a well-known
Yes.
word, right?
Yeah,
All
yeah,
I
yeah.
can think of are anal beads.
I was just
Anal
about
beads.
to say that.
What? That's
Is that just a common
stretch.
occurrence in your life
I
anyway?
know we're being all nice and ladylike with our string of pearls. Meanwhile, Curry in her
but the thing
dirty
is-
little corner
it's
over
because you
there.
said pearls and I was like a pearl
Pearl
necklace.
necklace.
And
And then you went straight to anal.
no,
beads.
because the image I had in my head of something like that, there's a string of things inside something. I was like, anal beads.
Oh my god.
Curry loves anal
Ding,
beads.
ding, 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 ding. You have about 10 trillion cells in your body. If you stretched it all out end to end, they'd stretch over 744 million miles. Your DNA would stretch to the moon and back 1,500 times.
Wow.
That's a shitload of...
But if you went to the sun, your DNA would only reach there and back 4 times.
Ah.
Good
It's not long
astrology.
then, is it?
Yeah.
No, is that astrology
It's not
or
that
astronomy?
impressive.
It's astronomy.
Astronomy,
yeah.
astrology.
Astrology's
Star
horoscopes.
Yeah.
Which...
Yeah. It's,
And
Is
if you
it
did that when
Okay.
Mars was waning, you'd be in a bad mood.
And then you just stroke your
kind
crystals.
of back to getting back to crystals, isn't it? We're talking about the energy and things like that.
So the key thing, if your DNA is wrapped around a histone, so it's wrapped around and then in parts it's not wrapped around, and then it wraps around again.
Oh, okay.
And those bits that aren't wrapped around the histones, they're more accessible and could be expressed more.
So that's the bit of the anal bead that hangs out so you can pull them out safely.
Definitely.
Yeah.
So any genes that are on that bit are going to be expressed more than the genes that
What
are
do you
wrapped
mean by
around.
expressed?
So yeah, so
Sure.
Yeah.
your genes encode the information to produce proteins. They do that by an intermediate called RNA. So the more RNA they produce, the more they're being expressed, and the more protein ends up being produced. So
And
if
then
that-
what does protein do?
Protein does all the functions that your cell needs to do. Your proteins are like the tools of your cell. They use it to do all the jobs that a cell needs to do. So yeah, the more protein you get produced from a gene, the more that gene is being expressed. So
It's
if a
like
gene,
having a dimmer switch on a light bulb, kind of,
Yeah.
right? So like the more you turn it on, then the brighter the light becomes.
Okay.
So it's sending more so the more you turn it on, it's producing more electricity or whatever, or it's like
More protein.
producing more current, or protein, and then the light becomes brighter.
Sure.
And then the cell works harder.
Got
so bits of DNA that are wrapped around the histones are less accessible for being expressed, so they produce less protein than the bits that are in between.
Sure.
So what chromatin remodelers do, sort of finally getting to what I actually work on. They alter the bits of DNA that are being associated with histones. So they sort of may slide the reel up and down the thread so that different bits are being wrapped around and different bits are being exposed. So they can change the expression of genes by altering the histones rather than actually interacting with the DNA itself.
Right.
So therefore you've got this non-DNA based way of changing gene expression, which is why it's epigenetics.
Right.
What does the epi bit actually mean?
I think it means like to the side of or something.
Oh, okay.
Something like that.
Other epi words.
Epicenter?
Epidemic.
Upon.
Yeah. So it's upon the DNA.
Upon
yeah.
genetic.
Right.
So these chromatin remodelers, there's tons of them expressed in your body, in your cells, and they all do have individual functions. And we're trying to look at ones that directly impact the growth of your brain. So they're really important, these chromatin remodelers. So a key point of biology is that every cell in your body has the exact same genes, but different cells require different genes to be switched on at the same time. So these chromatin remodelers are really important for making sure only the right genes are switched on in the right cells. So we look at the ones that can impact neural, like your brain growth and growth of your neurons, things like that. So specifically coming onto my project, I look at a gene called CHD8, which is a chromatin remodeler. It has been shown that humans who have mutations in CHD8, so they've lost the function of their CHD8, have a really high risk of being diagnosed with autism. I think it's about like a 90% chance.
Okay.
Which is way, way higher than most risk factors for autism. So autism is quite a complicated disease to study because it's got loads and loads of risk factors associated with it, but not many of them actually have that great an impact on its risk. So it's sort of an accumulation of lots and lots of risk factors that give you the disease.
But this is one that's
this one has a really strong effect, and what that does is it makes it really easy to model in an animal. Because all we need to do is go in and change this one gene, and we can potentially
cause that animal.
How does an autistic mouse behave?
Well, this is what we've done. We've gone in and we've changed this gene in a mouse and given it autism. We say there's big controversy in the field of what actually defines an autistic mouse, but we've done a lot of behaviour on our mouse. And the sort of tests you do is you look at social interaction.
In my head, this is so freaking cute. Like, you have this really aggressive mouse that's really angry, but this mouse is still plodding towards it like, hello.
It just doesn't know that it's angry.
So I don't know, in my head, obviously, everybody, whoever is born with autism, right? Or are there situations where people can become autistic, like in the middle of their life because something happened?
So, get a clinical diagnosis of autism, it needs to occur in a specific developmental time frame. I think it's like after 2 years old you can be diagnosed with autism. But there are environmental risk factors for it.
Right.
But again, not many of them are very strong.
And would they have to be in early life?
Yeah. So one of the biggest environmental factor, I think, is if your mum has an infection while she's pregnant with you, that the inflammation that she's having can transfer to the fetus and increase the risk of autism.
Did you take an adult mouse and change it to make it autistic, or did you?
No.
Was it a fetus of a mouse?
No.
And then
So
developmentally had it.
What we have is we've generated a colony of mice that have a mutation. So what you do to create sort of just any sort of transgenic mouse is you take the stem cells of a mouse, you take them out of a developing egg, take the stem cells out, introduce the mutation into the stem cells.
Right.
In a dish,
put those mutated stem cells back into a pregnant mouse, into her fertilized egg, and then she'll give birth to genetically modified mice.
Yes.
And you can then breed those mice, and any mice that come from those mice will also be genetically modified. So they'll all have the same mutation.
I suppose I'm kind of going down the rabbit hole a little bit then. Is there a guarantee that those genetically edited or changed mice will definitely produce autistic mice?
They should. So it depends on. So every gene in your body you have two copies of, because you have a copy from your mum, a copy from your dad.
Yes.
So if they have one copy that's mutated, they can have babies that are either normal or mutated.
Yes.
If they have two copies that are mutated, all their children will be mutated.
Of course.
But yeah, so it just depends whether you keep it. That's called either being homozygous or heterozygous. So it depends how you keep it.
Alice de Mulder and I just pulled very impressed faces at your question. That was a very good question.
Oh yeah,
we were all three of us were just doing the like.
You're like, oh yeah.
So you were asking about what defines an autistic mouse.
Yeah.
Okay. So The two key sort of clinical symptoms of autism are poor social communication and repetitive behaviours. So the way we assess that in our mice is we do what's called a social interaction test. So you put them in like a 3-chambered box. One chamber has another mouse in that they've never met before. The other has just sort of like a novel object, but that's like tends to be like a toy or something, but again that they've never seen. The idea is a regular mouse would want to spend more time with another mouse, so you sort of time the amount of time they spend interacting with the different objects. And in an autistic mouse, you would ideally see a reduction in the time they spend with the other mouse.
I don't know this, but are mice social animals in the first place?
Very,
They are?
yeah.
Okay.
Cute.
And
That's why the country mouse and the city mouse became friends. Does anyone remember that?
I'm definitely
In
cutting
a
that out.
story or a...
It was an old book about a country mouse and a city mouse.
No.
but the repetitive behaviours test is even cuter. So what you do is you put a load. So they're kept in cages with like lots of sawdust. You put in a load of marbles, and the idea is that a repetitive mouse is going to do a lot of digging. So the more digging they do, the more autistic like they do. So the more marbles that end up getting buried, that's like a measure of how repetitive they're being. So that's a nice little test.
That's so cute.
Yeah, that is
quite cute.
But if I was that mouse, I'd be pissed once some huge human comes in and takes away all my marbles.
Yeah.
So that's undoing all my hard work of digging.
Yeah, maybe.
You're a terrible person.
Yeah. So there's guys in our lab who do all that behaviour stuff, but what I actually do is what's called electrophysiology. So I record this come up before, and Kiri's talked about it, and she's afraid that I ridiculed her description of it, but I really didn't. Yeah, that is recording the function of neurons, so looking at the electrical activity of neurons.
Sure.
So the idea in the autism field is that it's caused by an imbalance in the amount of excitatory and inhibitory function in your brain. So
Explain.
Again, yeah, I was going to. In your brain, you have broadly two different types of neurons. You have excitatory neurons that excite other neurons, pass on their message, and get other neurons to fire.
Yeah.
Pew pew.
And then you have inhibitory neurons whose function is to sort of regulate that amount of firing and stop it getting too much. Because if you have too much firing, that's what leads to things like epileptic seizures. Is like an overactivity of your brain.
Sure. Okay.
And the idea in autism in general is that the balance between the two is off, and you get a slightly odd level.
In which way?
Unknown. It depends what paper you read.
Okay.
Some see more inhibitory, some see more excitatory.
And is it in a particular part of the brain, or is it
Yeah.
various parts of the brain?
So mainly the big area that's been implicated is the prefrontal cortex, so the front of your brain, and the cortex is the region that does all your sort of higher order thinking. So things like emotions, social interaction are all computed in that region of the brain. But it does so many things. It controls your movement and stuff as well. But so saying the cortex is implicated is a bit like, I don't know.
Saying your body is implicated in health.
Yeah, exactly. Yeah. Food is the problem in your diet. I don't know. Yeah. What we're trying to achieve with this mouse is we've got a gene that's easy to knock out, so we can model autism quite easily in a mouse.
Yeah.
And then we're trying to see what changes that causes in the brain and whether we can apply those changes broadly to autism to see if we can find sort of general mechanisms that are going wrong in the brains of these patients. So what I do is I go in and record the amount of excitatory function and inhibitory function in the brains of these mice and see if it's different from wild-type mice.
Right.
Wild type being normal.
Yes,
yeah,
so wild type.
So there's some sort of control then, I'm guessing.
Yes, so we were talking before about how a heterozygote mutant mouse can have normal babies.
Yes.
So I compare the babies of a mutant parent mated with a normal mouse. So they'll have half mutant babies, half normal babies, and I compare the two. So it's all quite tightly controlled.
So they're brothers and sisters.
Yeah.
Cute, but some of them are autistic and some of them are not.
So
like in real life.
Yeah.
So I've got another question. Maybe it's slightly sort of tangential, but
We love tangents in here.
Yeah, back
Tangential.
to the sort of I know that was a buzzword, wasn't it?
That's a
I could do
fantastic
buzzwords
word. I've never heard that word in my life.
So you were saying the fact of you were talking about the control or the wild, was it wild type?
Wild type, yeah.
Is that what you said?
That's
Yeah.
what I do.
How, so I suppose it's kind of coming on to like confounding factors and things like that. Like surely, because I'm thinking about when you go and see an animal in the zoo, they do repetitive stuff like they go back and forward, back and forward, back and forward, and also if they get depressed or things like that, they might become less sociable. How do you normalize for things like that?
So the way you do it, you just have to treat every animal exactly the same, other than its genes.
Then you would see a difference between them.
So then you assume that the only difference is because of the genes you see. So they're all they're housed together in the same conditions. They have the same parents. So you assume there's no sort of rearing differences
genes.
between the two. Yeah.
Yeah. Okay.
And the
As long
important
as you see enough of them.
the important thing, there's lots of different wild type mice. So there's lots of different strains of mice that different labs use that all have slight variance in their behaviours. So one of the other commonly used autism mouse is just a wild type mouse that was inbred over so many generations that it started developing repetitive behaviours, which is called a BTBR, if anyone's interested. And that's your model mouse for idiopathic autism, so autism that has no known cause. They model that with this BTBR mouse just because it happens to be a bit antisocial.
Oh, that's interesting.
Because it was inbred.
Yeah, but I mean, all mouse are inbred as well, to be fair. Like,
And that one wouldn't particularly have this genetic mutation.
no, so no one knows why.
Lots of those little
Yeah, that's exactly what they
contributing
think.
factors.
Yeah, so no one knows why this mouse has these social deficits, but
Right.
they found that it did. So they're like, oh, let's use that as an autism model.
I have two things on autism.
I feel like Curry, you're really enjoying being on the other side of the science.
I am. It's
during
quite,
this
it's quite
podcast.
fun. I've heard two theories of autism that I quite like. One I really like, but I'll do that second. The first one is that every single human is actually autistic. It's on an autistic scale.
Yeah.
But scientists tend to be quite a lot higher up on the scale than non-scientists. Is this true? Are we all autistic in here apart from Reese?
I would say there's, when people say there's the spectrum, not everyone is on the spectrum. To be on the spectrum, you need to have that diagnosis of repetitive behaviours and social interaction.
So you can't have someone that's not autistic on a spectrum. Like, is there a...
We're all on the spectrum, man.
See, that's what I thought.
Yeah.
But no,
Wrong.
so the reason they call it a spectrum is because the severity of symptoms in individual autism patients varies wildly. So there's a spectrum within autism.
Okay.
But that doesn't mean that everyone is on the spectrum.
Okay, yeah.
Also, I really like this theory, but I've heard from some scientisty people that some people think that autism might actually be the next stage of evolution.
I've heard this as well.
Where, because a lot of autistic kids have those super memory powers and super math skills and all that kind of shit, that maybe actually autism isn't a developmental disorder, it's the next stage of evolution.
So what you're referring to there is what's called savants.
Yeah,
so
yeah.
These autistic people with like mad skills.
Real life
mad
superheroes.
skills, I think they're called.
Isn't
Scientifically known as mad skill.
But I think the prevalence of those sorts of people has been really exaggerated by the media, because you see they come up a lot.
Oh, no.
Because they
I succumbed to the media.
No.
they are really interesting, but I think I maybe fact checking Demelza can look this up, but I think the percentage of autistic people that have savant skills is like less than 1%.
Pretty fucking cool though.
I feel like there's different levels of that too, though, right? Like I feel like a savant usually is someone that has really like crazy like specialization in things. They'll have like synesthesia and things like that. That's where your senses you can start to taste numbers and like feel music and things like that, as opposed to someone that is maybe just like very detail orientated and good with numbers or something like
Ding,
that.
ding,
Yeah,
ding.
I'm sorry.
Silent Demel's fact. The estimated prevalence of savant abilities in autism is 10%. So that's actually kind of high.
Okay, that's higher than I thought.
Whereas the prevalence in a non-autistic population, including those with mental retardation, is less than 1%.
Okay, fair enough.
So 10% from an autistic population is quite high.
But then, what is defined as a savant? Like that's what I'm trying to say. Is it someone that can recite pi to 25,000 decimal places, or is it someone that is like 10% better at math than?
I think it feeds into this repetitive behaviours side of autism, is that they become fixated on one thing and they become extremely good at that one thing.
Yeah.
If you put them out of their area, then they're not as comfortable.
So So it's almost like they might not necessarily have better aptitude towards it. It's because of the nature of being so repetitive in one thing that they actually just get very good at it.
Partly, yeah, but then equally, I think some of the most major breakthroughs you're going to make are only from people who become obsessed with something. So maybe we put too much of an emphasis on trying to be good at many things.
We have more silent demands effects. So people working in science and engineering are more likely to have autistic traits than less technical professions. And this survey thing that they did with the public also confirmed that men tend to be more autistic than women. And the questionnaire, which is called the Autistic Spectrum Quotient, was developed at Cambridge Uni, led by a guy called Professor Simon Baron-Cohen, who is...
That is Sacha Baron Cohen's dad.
Yeah.
Yeah.
Wow, freaking cool!
He's a big name in the field.
Yeah,
Stop. I never knew that.
Is it his dad or is it his uncle or something?
Oh, his uncle. His cousin.
Was it?
Oh, it's his cousin.
Oh, really? I thought I remember reading that his dad was a professor at Oxford or something like
Cambridge.
that. His cousin is also...
Very well-educated family, I think.
Okay, so it's someone else.
I mean, Sacha Baron Cohen is smart.
Very
Yeah.
Just chose a different path.
Yeah, used his genius in a different way.
I think it's gone.
Kiri, any questions about electrophysiology?
No,
Get off your chest.
I don't care about electrophys.
Sort of neuroscientist to you.
Electrophys is cool. Electrophys is hard though. I don't really understand electrophys.
You need to... I had to go... When I first started, I knew nothing about electronics, so I had to go back to GCSE bite size to remind myself what voltage and current was.
Yeah.
That's the position I started from. So you can get good.
I think it's every part of biology that overlaps a lot with physics. I'm a bit like, nope, I'm out.
Yeah, me too.
Can I ask a bit about it? I know that you spoken about it in previous podcasts.
Well, apparently it was all inaccurate information, so ask all you want.
I'd never said this.
correct all the information Kiri's ever given them.
You didn't go into that much detail,
No,
but I don't think you ever said anything wrong.
You didn't like how I said we stab the cell.
Oh yeah, true.
Yeah.
It's difficult. So yeah, Kiri was talking about a specific type of ephys, which is called patch clamping, which is what I do, which is putting an electrode on a neuron. So what I do is I dissect out the brain of a mouse, slice it into sort of thin sections, have them under a microscope, and then you have electrode coming down, which is like a glass pipette with a wire inside, and you fill that pipette with the same sort of stuff that's inside a cell.
Right.
And then the tip of the pipette is like really, really, really small, but it's hollow and round. Put that onto the surface of your cell, and then you just sort of suck.
Yourself?
Yeah.
What?
It's linked. It's
You don't.
You do. So it's linked.
This is barbaric.
Very precise.
It's linked through some tubing to this little suction thing you have here, and you just.
What if you suck up the cell?
You have to be gentle.
No, I don't.
Oh my god,
believe
I
you.
would eat so many mouse brains if I had to do this. What the fuck?
There's a lot in between you and you're not going to inhale the cell, and the tip is if that's the again visual cues, but the cells are 100 micrometers big, and your pipette tip's 5 micrometers big, so it's not going to fit.
Okay.
But you just touch it to the surface and you just go like that, and it seals the
I
surface of
can't
the cell.
believe this. I never
is
knew you actually sucked on it.
And it breaks the surface.
Surely not.
Breaks the surface of the cell, so it's now essentially your wire is inside because you've got full connection between the inside of the cell.
Are you really telling me, as far as technology has come, they haven't
make you
found
suck
this
cells.
way?
Yeah, it's
to
the best
give
way.
To give
That's
the
the most
perfect
cells.
amount of suction onto this pipette.
It's the most controllable. Some people, there's a zap function on most amplifiers that's meant to do the same thing, but it's not as good.
Oh, so you don't.
Wasted 10
Have you
minutes
ever
more.
sucked it up the pipette?
When I was first learning, yeah.
What does that feel like?
You know, it doesn't
Does it go in your mouth?
You can only tell from the you have a readout of the electrical activity, and you can tell when it's just
Gone.
fucked.
When it's essentially in your.
There's a lot of stuff
you've
in
digested
between
it.
the thing that you're sucking on and the actual tip of the pipette,
okay.
so it would have to go through a lot of things to make it to your mouth.
Yeah.
So I wouldn't worry about
okay.
that.
Okay.
So there's filters.
I've seen an electrophys set up once in real life, and it was really depressing.
Why?
It was just this really dingy room
Yeah.
with this machine, and I just thought, and everyone was on their own doing it, and I was like, if this was I think I'd be quite depressed.
I quite like it because I can just put a podcast on and just chill.
A
You get-
podcast
lay it out podcast, and you get in a zen state where you just patch a cell,
Just you and
do
yourself.
what you need, and then
So-
move on to the next one.
So then once you have sucked the appropriate amount and you have it there, what then happens?
How technical would you like me to get? You do a thing called voltage clamp. So your electrode's linked up to an amplifier which can inject current into your cell and also record current from your electrode. So what you do is you set a voltage that you'd like to clamp your cell at. So your amplifier records the voltage of the cell, sees how different it is from the one you want to clamp it at, and then injects the amount of current to bring it to that voltage, and then holds it there that way. And then any sort of activity that the cell undergoes that's going to change its voltage will then change the amount of current that your amplifier is having to inject into the cell.
Sure.
So then you just get a readout of how much current the amplifier is injecting, and that tells you what currents are going in and out of that cell.
Cool.
So it does it that way. So it's a bit of an indirect measure, but it tells you what you need to know.
Cool. Should we move on to your paper?
Do you want to?
Yeah.
So this isn't really to do with the brain, but it is to do with chromatin remodeling, which, as we remember earlier, is when you change the interaction between histones and DNA to change genetic expression. So one of the things that impacts how histones interact with the DNA is whether they're methylated or not. So whether they have these little additions, these methyl groups, and that changes their interaction. So what this paper did, they changed the histone methylation inside the sperm of mice, and then saw what impact that had on the offspring of the male mice that had this modification. And what they found is that it caused like really bad developmental defects as these mice got older. So they've called it "Disruption of Histone Methylation in Developing Sperm Impairs Offspring Health Transgenerationally." It's not too bad of a title. I think it sums it up quite well.
Transgenerational, as in it doesn't do anything to the mice whose sperm are changed.
Yes.
Their
exactly.
offspring.
Yes. So what?
Transgender, like you were born in one generation and you think that you actually belong in another.
You transcend generations.
I think I'm quite transgender.
Yeah, I think maybe Rob is.
One of the really interesting findings that I'll come on to is that they actually found if your dad had this mutation that caused this altered histone methylation, but you didn't inherit that gene which caused it, your children could also have these developmental defects. So the idea is that things going wrong in your granddad could affect your development as well.
Shit.
I'll go into how they came to that.
Is that like the way
conclusion.
they say certain things skip generations? Like, you know, the way apparently twins.
Not in the same way.
Okay.
No.
Okay. Thank you. That's a satisfying answer.
So, shall I crack on?
Yes, crack on.
The reason they did this, birth defects is what is essentially the field that this lab is in, and they noticed that in the sort of public knowledge, people tend to put the emphasis on preventing birth defects on the mum. So when the mum's pregnant, she shouldn't drink alcohol, she shouldn't smoke, all that sort of thing.
Yes.
And they were like, hang on, what are the dads doing wrong? So they were trying to see what impact.
That's right. The
Yeah.
men
What
are always
inequality.
doing something
the
wrong.
health of your sperm.
Can't build car parks properly and they're fucking up their
Yeah,
sperm.
exactly. So they were trying to see what impact like the health of the father's epigenome could have on the development of the offspring. So what they did is they overexpressed a gene called KDM1A, which encodes a chromatin remodeler, similar to the CHD8 that I was talking about earlier that I work on. They made it active only in the sperm of the male mice. So therefore, the sperm of these male mice had far too much of this KDM1A chromatin remodelers.
Did they have autistic sperm?
Different gene.
We've moved away from autism.
Oh, sorry.
We're on to birth defects.
Yeah. So the function of KDM1A is to demethylate histones, so it takes off these methyl groups from the histones, so it's changing the interaction of the histones with the DNA. So therefore, if you overexpress it, way more methyl groups are being removed than should be, so you're screwing up the epigenetics of the sperm of these mice. And they then it's good that we talked about this earlier, actually. So the male mice were heterozygous for that gene, so they only had one copy.
Yep.
So therefore, in their offspring could also have the gene, or they could be normal. And then they traced the impact of that gene over multiple generations and saw what happened to the mice as they got more and more exposed to that gene. First thing they did is determined that expression of this gene didn't actually affect the sperm in any way. It didn't screw up the male's testicles. They found that their testicular size was normal.
Good for them.
Yes. And spermatogenesis was fine, and it didn't damage the DNA or the genome.
Spermatogenesis being the production of sperm.
Production of sperm, sorry, yep. And it did not damage the DNA of the sperm, so it was only acting on the epigenetic level. So then what they did is they started assessing the survivability of the offspring of these mice.
Is that a word?
Survivability, so how well they survive.
No, I understood what it meant.
Yes,
Yeah, it's a word.
It is a word.
Same as,
Yeah.
probabilizing. Same.
So what they found is they compared how well the babies of these male mice that have the transgene survive compared to mice with normal dads who don't have this mutation, and they found that it was significantly reduced. And if they had a baby of a dad who also had this mutation, they assessed that mouse's babies as well, and they found that as you went down the generations, survivability got worse and worse and worse. So
is that like stillbirth or actually like born alive and then died very quickly?
So what they did is they traced, so they would just literally record how many mice were still alive every day for 22 days after they were born.
So after birth.
So in a normal mouse, they had about 90% of the babies would survive until 22 days. After 2 generations of exposure to this transgene, by 22 days, you only had about 60% surviving.
Okay.
And by 3 generations, it was around 30%.
Oh, wow.
Oh.
So the idea is the more each generation you get more exposure to this gene, your epigenome's getting more and more screwed up, and it's getting worse and worse.
Your third generation is like great grandkids.
Yes. So that's not unexpected, because we know like each time you get exposed to this, it's going to screw up your genome a bit more, so you're going to get worse and worse defects, and survivability is going to go down. But what I think is the coolest finding in this paper, so we talked about how it was heterozygous, so you could have normal babies being born and mutant babies being born. What they also found is the offspring of a mutant dad, but who didn't have this mutation, their offspring would also have reduced survivability.
Oh.
So this is someone whose granddad had the mutation, whose dad didn't, and they don't either.
Right.
But their survivability was down to about 75%. So significantly different from
Did they figure out why? Because it wasn't, even though it wasn't impacting them.
That's what they try and go through later on in the paper. We'll come to that. But the true answer is no, not really. But they suggest some ideas.
Just apologise to anyone who hates mouths.
Oh, sorry. Did I slur?
For the slur.
And also, like, you tried to get it in so
Yeah,
quick
you were like-
before your next word.
So they've seen this reduced survivability in these mice, but they'd also noticed just from like sort of looking at them day to day that they also sort of showed these abnormal growth defects. So they wanted to assess that in a bit more detail. And what they also suspected is that unfortunately mummy mice are a bit mean. And if they have any sort of
They eat them.
defective children, they'll eat the defective children.
Well, I
so
mean,
they
you
thought
know.
they could be underestimating like, the
Circle of life, eh?
severity of these effects.
Are there other mums mean, or are they just saving their children from a lifetime of...
I mean, out in the wild, I can see perfectly why they
energy
do it.
conservation,
Yeah,
isn't
exactly.
it?
Yeah. It's
Yeah,
about to get a bit more graphic. I apologise for this.
Okay,
So what
we'll
they,
put the disclaimer in now.
yeah. So what they did now, they were worried that they maybe were underestimating the severity of these defects. So they didn't let the mother give birth to the babies. They would dissect the babies out when they were pretty much ready to be born, but she
Right.
didn't have a chance to give birth and
Ooh,
eat
maybe
any
we
that
should
were grim.
Yeah.
So a mouse's pregnancy is normally 20 days old. When the embryos were 18.5 days old, they dissected them out and sort of looked at the lump for any sort of gross abnormal development.
Question:
Yes.
did they die?
Yes.
So they didn't live at all.
No.
Okay.
No, and mice don't actually feel anything until until they're like 3 days old, I think.
Okay.
So yeah, all this was done in accordance with the ethical guidelines of the Animal Act 1986. So for this, they assessed the amount of pregnancy loss in females and the proportion of embryos and fetuses that were abnormally developed. And what they found is that the transgenic fathers had more litters that were lost, so more pregnancy loss compared to the wild types, and also a severely increased number of fetuses that had some sort of developmental defect. So in wild type mice it was less than 5%, but in these transgenic mice with the mutation it went up to about 25%.
Wow.
And with the ones that were, like we talked about, whose granddads had this mutation but they didn't, their litters would be about 10% genetically.
And would there be? I'm guessing it's probably quite a sort of complex knock-on effect of what could actually happen. But would there be any like particular deformity that would actually be found? That would be the thing that would be the cause of death, or not?
So it was really wide-ranging. So they were a bit kind of not sneaky is not the right word, but they essentially hedged their bets really well with this. With the gene they chose, this KDM1A, its function is to regulate genes that are vital for development. So like the very basic core things that set your body up in the right way. It controls those genes. So by impacting that expression, you're going to have really wide-ranging effects on development. So the sort of things they would report were skeletal abnormalities, so their limbs wouldn't develop properly, blunted nose, their face and skull wouldn't develop properly, and things called like hemorrhagic foci. So this is where like your blood vessels have not attached to each other, and they're just sort of spitting out blood into.
Wow.
It's not,
Oh god.
Okay.
it's not nice.
Okay.
It's like making vampire babies.
Yeah, no, this is like real, like sort of evil scientist type stuff here.
Yeah, it's not it's not the nicest paper, but it's interesting, I think. Maybe that reflects badly on me. Yeah, so the key is really badly deformed babies in the ones with the transgene, but also the ones whose granddad had the transgene. They were also siring pups with these defects. And then the final thing they did, just because they'd noticed that these skeletal abnormalities were happening, they did a much more in-depth look at the ossification, so the formation of bones.
Right.
And these mice, so they did a stain. So that,
Ossification, that's a nice word.
so they, you can do that. There's a commonly used stain which stains bone red and cartilage blue, and they just compared a normal mouse to the pups of these mutated mice, and found that they weren't really forming bone properly, which sort of explains the abnormalities they were seeing. But they do state, and I agree with them, that they probably underestimate the amount of things that are wrong with these mice, because it's like impossible to do the number of experiments that you would need to do to find everything that was wrong with them, and it's pointless really. Like the take-home message is they're really screwed up, and it's because of this transgene that they caught and the alteration of the histone methylation. So now they wanted to move on to why is this happening? Like, what is the actual mechanism? So their initial suspicion was like this gene that we're overexpressing, this KDM1A, its function is to take off methyl groups from histones. So why don't we just look at the amount of histone methylation that's going on? And what they did is they compared normal mice with the transgenic mice, so these mice that had the KDM1A in their sperm. And I should say they did this all in the sperm. So they took the sperm out from the mice and looked at the histones within the sperm.
And then did they put the sperm back in?
No. So they were just sort of they take the DNA out of the sperm and look at the DNA of the sperm. And then also these mice whose granddad had the gene, but they themselves didn't.
Yeah.
And they compared between the three. And what they found was that, as you would expect, the ones that had this KDM1A overexpressed had much reduced methylation. But what was surprising, as they still had the defects, the non-transgenic mice didn't show any difference to wild-type mice. So these normal mice. So they were a bit like, we thought that was what was causing it, but that isn't any different, so it can't be. The methylation. So then I imagine they scratched their heads and were like, okay, what are we going to look at now? And then a good chunk of this paper is just sort of failed attempts to try and find things that were wrong in the non-transgenic mice, which
negative results.
Which are negative results. So I won't bore you with those, but they tried a few things. But what they eventually did find something that was different. So what they eventually looked at was the amount of RNA that was in the sperm. So we talked about RNA earlier, which is the amount of expression that genes have, is the amount of RNA that they're producing. And what they found is that both the transgenic and the non-transgenic mice had reduced amounts of RNA in their sperm. And crucially, it was pretty much exactly the same genes that were being reduced between the two. So like, same thing's happening in the two. This is probably what's causing the defects.
Right.
So what they're proposing is that you screw up the methylation of the DNA, of the histones. That's altering the genetic expression of the DNA. Therefore, you're getting this reduced RNA expression in the sperm of these mice. And there's another step on from that to determine why the reduced RNA actually causes the defects that it causes. So what they did is looked at what the impact of the reduced RNA in the sperm actually has on the offspring. So again, they mated the mice together, and they took the transgenic and the non-transgenic embryos when they were just 2 cells big. And what they found is that this transmission of this altered RNA sperm had a knock-on effect in the embryos of their offspring and changed the expression of genes in the 2 cells of their
Okay, so
offspring as well.
literally from the very beginning then.
Yeah, so things are being screwed up immediately upon conception, and that's what's giving rise to these defects, they suspect. And that's where they end. And fair play to them, they did a lot of work to get to there. But it does leave a lot of questions unanswered. Essentially,
Why does this matter?
why does this matter?
Yeah, like, what's the point? Because I think with a paper like this, it's quite hard to relate it back to us.
Yeah, real world.
Real
right?
life.
Exactly.
Yeah.
Okay, yeah. So the big conclusion of this, I assume what the press would take from it. So the big thing about your epigenome, so your epigenetics, is that they can be affected by the environment. So things like smoking, taking drugs, amount of exercise you get, stress, have all been shown to directly change your epigenome and change your interaction of histones with your DNA. Whereas your DNA stays the same largely throughout your life, your epigenetics is constantly changing in response to your environment. So what they're saying here is that this can have huge effects on the development of your offspring if your epigenome gets really screwed up. So their take-home message is, men, look after your sperm, because it can have it can not only affect you and your children, it can also affect your grandchildren and their grandchildren.
Well,
later
isn't it
on
a
down
good
the
thing
line.
that we don't have emo boys walking around with super, super tight, skinny jeans anymore?
Yeah. The point I want to raise against that is what they've done here is really severe. So overexpressing this gene really, really, really screws up your epigenetics.
To a degree that environmental stresses would not.
Exactly. So the question that I and to be fair, they raised the point as well, is like it's still unproven whether any sort of natural stimulus could influence your epigenome to the extent that their one did.
Yeah. I mean, so that was kind of, I had a question on that. Yeah, there's the level of severity to influence something to happen like that, but do we even have an idea of what environmental stimulus could cause this to happen?
Yeah, so there's a paper on pretty much anything you want to
Really?
talk about. So like people have shown smoking can change your epigenetics, stress can change your epigenetics, the amount of exercise
But
you
in
get.
this particular way?
No, so I don't think anyone would be able to pin it down to like an individual gene check. So when you're doing this experiment, the way you quantify it is you look at like the level of histomethylation, say.
Yeah.
And you would make someone do a load of exercise, make someone not do any exercise, and you would compare the histomethylation between the two. And they would probably be different. But you would have no idea what caused the difference. You would just know exercise was the changing factor, but you don't know what the cascade of things that happened after that to result in that altered methylation would be. So you couldn't pin it down to like an individual gene like they have done here. And in all likelihood, it wouldn't be as severe a change as we've seen here. So
Okay, but from run-of-the-mill things that you're talking about, like your fitness level, your smoking, your drinking, your drug taking, like that would be something you would see demethylation of.
it could be demethylation, it could be more methylation.
Okay,
it could
so
be,
it could impact it. That's interesting.
they all impact it, and there's so many things that are considered epigenetic changes that you can find anything that is changing,
If you look
because
hard
there's so
enough.
many things to look at.
Yeah.
This is like the whole thing of like everything gives you cancer. Like
Yeah,
Yeah.
You're
it's a
getting
bit
to
like
that
that.
fucking
point, aren't
hell.
you?
But I think it's still a science. It's in a bit of an infancy. So we're still getting to grips with what all these changes actually mean and how they interact with one another.
Yeah.
And it's so complicated that it's hard to make definitive statements like about what causes
Yeah,
what.
of course.
Yeah.
And do you think it's like you were saying earlier on that there's probably in diseases that do happen in humans, or things that lead to like epigenetic changes that lead to negative consequences in humans, it's not going to be one thing, it's going to be a few.
Yeah, almost definitely.
Yeah.
And like similar to autism, it's going to be like an accumulation of multiple small risk factors that eventually lead to big effects rather than like one big change.
Yeah.
I'm having a mini crisis.
So it's not like one no, it's not like
Must
one
be
needle
healthy.
it's not one needle in a haystack, it's like 10 needles and you have to find them all.
In a needle stack.
Yeah.
Oh god. Can't deal.
It just makes you feel how fragile you are, and
Yeah.
I think what they did is what a lot of scientists do, and you can't publish a paper unless you see an effect. So you always want to hedge your bets and try and get as big an effect as possible. So they've targeted this gene which is impacting on the expression of lots of really important genes, and they're ramping it up to such a degree that they're almost guaranteed to see something. So it's a really artificial situation that you probably wouldn't see in nature. So
to that degree.
Yeah.
But on a smaller scale.
You would, yeah, like you see changes like this on a smaller scale, but it's like, I don't know, saying, let's try and think of an analogy, like smacking someone over the head with a sledgehammer is what they've done here, whereas
We just want to give them
just
a pat.
Tickling them with a feather.
Yeah, nature. No, maybe not tickling them with a feather, but nature would be like tapping you on the head multiple times.
I like nature more. You're a dick.
So yeah, the outstanding question is whether things like this do actually occur in nature, or whether this is just like a cool phenomenon they were able to produce in the lab. But I thought it's the most spectacular example I know of epigenetics being able to truly have an effect and show
It's
how
very
much
cool.
it is.
I think the idea of epigenetics, if you actually get to what it is really cool.
Problem is, it's so unintuitive. I didn't learn about it until like third
To
year.
be honest with you, every time I've learnt about epigenetics before today, I've been bored as fuck. but this has actually been really interesting.
So basically, Rob, she's giving you a compliment indirectly.
This is the first time that someone's taught me about epigenetics, and it's actually been really interesting.
Yeah, a lot of scientists sort of like poo-poo it, to bring poo into the
Because we haven't actually mentioned it.
We have to have it.
Because like a lot of them who aren't epigeneticists feel like we were getting on fine with just genetics for so long. Like, how much of an impact can this actually be having? Because like we've known about how genetics works for like almost 100 years now, and it's told us so much, and it works. So we know it. We know what it is. So when people came along with this whole new level of control over what genes are expressed, they were like, yeah, but we've known how it's worked for ages, so how can this can't be having that much of an effect, because we've been able to work things out without it. But I think this paper shows that it does really do something.
That's kind of what's been going on with neurogenesis as well, though. So like people had this strong idea that we don't keep producing new brain cells, and then people come in like, actually, look at this. But it's been hard to find real proof. Well, with rodents we have in animals, but not in humans. And I guess with this epigenetic stuff,
Yeah, you'd never be able to do this in a human.
Slight ethics problem.
It's just slight.
One final thing I wanted to say, because I think it's really cute. It's grim for a bit and then cute. But
That's my favourite kind of cute.
the way they would
Just
like
makes the cuteness that much more extreme.
the way they isolate the sperm for like all the DNA tests is they would cut off the epididymis, which is the bit that connects your sperm to your, and then they'd put it in a beaker with saline. And then the sperm would be collected by swim out, is the technical term they use. Just imagine these little sperm just like, freedom! Where are we?
How did we get here?
This isn't where I was expecting to be.
That just reminds me of
Where the ladies at?
Have you guys seen Look Who's Talking?
Yes.
And when they're having sex, and then the sperm's like going like,
and they're all swimming down the fallopian tubes and like talking to each other.
yeah.
Oh, amazing!
I love that movie.
That's a great movie.
I haven't seen it.
It's good. You should watch it.
I'll watch it. What's
John
it called?
Travolta in his prime. Look Who's
You'd
Talking.
enjoy that first scene as well, because you can imagine that's what all the little sperms.
Yeah.
They're literally all like, "Hey man."
Yeah, it's a good movie. I've decided I'm always gonna say penis and vagina to my kids. From the moment they can understand words, I'm gonna be like, this is a penis and this is a vagina.
So they don't go around saying dick and fanny.
No. Just like I want them to know. Like
The way you said it first, I was like, they're the only words you'll ever say.
Oh, what do you want to eat today?
You might give them a complex. Like a penis complex. You never know, you could screw them up psychologically.
I could. Maybe
don't do that.
Oh, fine. Do you have any final thoughts, Reese?
No, that was great. I feel like I learnt a lot. Didn't that sort of
Yeah.
stuff? So, like,
You
I was,
asked some really fucking
You're a
good
question
fucking questions,
asker.
though. Yeah, like those were like some proper. If we were having a journal club at work, the sort of questions that would come up.
good. I'm glad.
I think part of being a scientist is realising how little you know. It really grounds you in how complicated things actually are.
Yeah.
And, like, you'd never have any faith in being
Oh, don't,
right
I'm
anymore.
gonna have another crisis.
I think it's a really big problem for science as a whole. I think we need to be more assertive because we're so scared about being wrong all the time. And
Yeah.
we
Yeah, I
always,
think
we always
that's,
say
I think that's
it
a
is.
massive problem.
Yeah.
actually.
we just say maybe,
Yeah, or
Yeah.
it
It's
looks as
possible.
though there is evidence.
Yeah.
and then someone like
To
Donald
suggest.
Trump comes along. He's like, I will fix all problems in the world, whereas a scientist candidate would be like.
I will.
We
There's
doubt
there's
ourselves.
potential in 5 years' time that I may generate a specific p-value.
Yeah, exactly.
It's so true.
Yeah.
Yeah, because even when you find something as well, that's never the end.
Yeah.
Yeah, there's
But,
always a
Okay, well
deeper
then I
layer.
have to see what this does.
but we'll always have a job.
Forever and ever.
If you can raise the funding.
Oh, yeah.
The fun part.
Yeah. We'll be poor, but employed, but permanently stressed. It's a great
And
life.
permanently doubting our intelligence.
Yeah. Science is great.
In saying all of this, I love science.
Me too.
I do. I can't imagine myself doing anything else. I really can't.
Thank you, Reese. Thank you, Rob.
Thank you very much for having me.
Did you have fun?
Yeah, it was awesome.
Did you have fun?
It was stressful, but I think I
It makes
enjoyed
you
it.
think about your work in a different way,
Yeah.
doesn't it?
Yeah.
Thank you, guys. This was
Thanks
great.
so much.
Thanks for
We've
having
really
us.
enjoyed
Thank
our
you.
first
Yeah.
podcast where we actually haven't been the
Chatting
main-
shit.
Yeah. Although I've kind of missed chatting about shit.
Okay, well, anyway, thanks for listening. If you listen to us through iTunes or any other podcast app, please rate us, give us 5 stars. We'd really appreciate it. If you want to email us, you can do at layoutpodcast@gmail.com.
You can follow us on Instagram and Twitter on @layidoutpodcast.
And you can read our lovely blog written by the silent Demalza at layoutpodcast.wordpress.com.
Bye-bye.
Bye! Oh, and CoFresh sponsor. CoFresh, we know you exist because you've seen tweets and you retweeted a tweet about us. So we know you're listening. Our snack bowls are very empty right now.